Hello. Today I want to show you FireflyProtector, a software security solution designed to safeguard executable integrity against reverse engineering, tampering, and unauthorized analysis, built in 3 months. A big thank you to the teams behind Cpprestsdk, LIEF, Capstone, ImGui, and VM Protect. Their tools and contributions made this project possible. To demonstrate the efficacy of FireflyProtector, we will use this standard executable, cheat.exe, as our test subject. As you can see, it runs natively with 0 restrictions. In its current state, it is completely vulnerable to analysis and debugging. This is the FireflyProtector interface. It features a fully responsive UI with native dark and light mode support. We begin by selecting our target binary. The engine automatically parses the PE header, preparing it for the encryption layers. We will now protect the executable and run it first without debugging. It executes just fine, as expected. Now let's attempt to reverse it. I am launching x64dbg. Watch what happens when we attempt to attach the debugger. The protection engine detects the debug port attachment, instantly crashes and corrupts in runtime. If we are trying to attach the debugger in a fully unpacked state, it will not work as well. FireflyProtector also employs advanced environment heuristics. If we were to run this inside a virtual machine like VMware or VirtualBox, the application would refuse to launch. You can enable the option to lock the file name, for example, to loader.exe. If the name is not loader.exe, it will not run anymore. Static analysis is often the first step for a cracker. To counter this, we utilize string and resource confusion. We can inject up to 1 million junk strings and randomize resource tables.
An ocean of noise. Finding a real string or reference here is like finding a needle in a burning haystack. Next, let's look at the File Checkup module. This ensures that specific dependencies are present and untampered with. I am linking our protected executable to extremeinjector.exe.
As long as the verified file is present, the software launches. But the moment I remove or modify the dependency, the handshake fails and execution is completely blocked. Taking this a step further, we offer auto-execute and extract. The protected binary can securely carry a payload, extract it to memory or disk at runtime, and execute it automatically, seamlessly bundling complex dependencies into a single file. Finally, we wrap the entire package using the Firefly wrapper. Let's scan the file with Detected Easy. Usually, scanners identify the packer immediately, but here, the signatures are scrubbed. We also offer a Discord reporting module for real-time alerts. However, as you can see by this warning, we advise caution. Embedding webhooks directly into client-side applications creates a potential vulnerability if the webhook URL is extracted. While FireflyProtector obfuscates this data, for enterprise-grade security, we recommend server-side verification. For strict distribution control, we utilize hardware ID locking. This binds the executable to the unique hardware fingerprint of a specific machine, including the CPU, motherboard, and drive serials. In this test, I have locked the file to my PC. It runs perfectly. But if I simulate a mismatch, as if this file were stolen and run on another computer, the engine rejects the hardware signature and refuses to initialize. We can apply a custom manifest for administrative privileges. We can enforce a time lock, rendering the file useless after a specific expiration date. And we can enforce a country lock. As you can see here, blocking my current region prevents the software from running entirely. We offer custom string manipulation. Standard security warnings like debugger detected often tip off an attacker. Here, I'm replacing the detection warning with a generic, confusing system error code. When the protection is triggered, the attacker sees this fake error. They're led to believe the software is buggy rather than protected, wasting their time chasing false leads.